Okay guys, so we're going to be looking at what we do in the case of this kind of equation. I'm hoping that you've tried it yourself and now you're going to be seeing what we can do with it and perhaps answer any questions you might have had along the way. Okay, so first off, what we want to understand is that this equation is basically asking you what is the solution when this graph on this side intersects with this graph on the other side. So we're essentially looking at two different graphs. I want you to keep that in mind. So when we're looking at this, let's just start writing her out. I got x over 2x plus 5. And let me just say, the first thing I want to do is solve algebraically. This is my first thing I have to have in my mind. And I want to put 2x. I want to have this both with the same denominator. So let's put this all over 2x plus 5 as well, which means at the top I have to put 2x plus 5. And that equals 8x plus 15. This is interesting actually. I have a 2 outside of 2x plus 5. Which means I can make all these under the same denominator if I say this is actually over 2 times 2 over x1, and this one's over 2, which means both of these I need to multiply the tops by 2. So it would be 2 outside of all brackets, this whole thing. I can actually solve this whole thing, and what's nice about it, if I have them all under the same denominator, I can now get rid of that denominator. So I will be left with 2x plus, now this is a little wonky, but 2 times 2x plus 2 times 2x, so that's 8x squared, plus, now what is that? 2 times 2x times 5, so that's 1020 plus 20x equaling 8x plus 15. It's not scary. In fact, all I've got here is a quadratic, so I know that I'm going to be dealing with two possible solutions. And before I do that, I want to make sure that I've looked at my original equation. Now, like I said, I could almost look at this as being 2 outside of 2x plus 5. So I have, for the most part, only one situation where I have a point of discontinuity for this entire thing. And that only happens where x, well, let's just spell it out. 2x plus 5 cannot equal 0. I can't have it equal 0 no matter what. So that means x cannot equal negative 5 over 2. Okay, so let's go back to what we were doing. Just a little aside there, and it'll be pretty obvious in a minute why I needed to know that. But that is the really, honestly, the first thing you do is you check for any kind of discontinuities. Where can I not have x? Because you never know, it might interfere with things. So I'll be left with an 8x squared, 20 plus 22 minus 8 gives me 14x, and then I got a minus 15 equals 0. I know what to do with that. I'm going to be needing to break up that 14x to give myself some common factors. It's got to be adding up to 14 and multiplying to get me 8 times negative 4, negative 120. Well, actually 20 times 6 gives me 120, so okay, it looks like it's pretty obvious. 8x squared minus 6x plus 20x minus 15. And now I can break these things up. I'm going to be left with, what do I got here? I'm going to have a 2 outside, 2x, sorry, outside of a 4x minus 3. And then in this case, I could probably take something out. Can I get a 4? Yeah, sure I can. I got a 5 outside of 4x minus, yay, okay, so I've got a nice common thing going on here. I'll be left with a 2x plus 5 outside of a 4x minus 3. So I'm getting some roots here. And what does this mean? It means x equals either, let me see, negative 5 over 2 in this case, or x must equal 3 over 4. Now, I just said earlier that x can't equal negative 5 over 2, which means that this solution, and You can see why I did that first. Can't be included. I'm saying x is equal, no, I just said earlier I can't equal that, so therefore that's out of my solution. I only have one solution in this case, 3 over 4. Now the important thing to understand is, what am I trying to say with that 3 over 4? Well, essentially what I'm saying is that this is not a root in the traditional sense of the word. We're not saying that this is a root. We're saying that this is the point where both of these two separate graphs intersect. So somewhere, I'm going to assume that somewhere along x equals 3/4, somewhere around here, along this line, I should be able to find my two graphs. I haven't drawn this very well, but these two graphs will intersect somewhere along the line. Remember, this is not an asymptote. This is not a zero root or a root of any equation. This is simply somewhere along this line I expect to see both graphs intersecting at that point. So my next thing I have to do then is graph both. That's what's coming up now, so let's take care of that. Okay, so let's start. We can pick either side to graph first, but I'm gonna pick the right side. It looks the easiest because I recognize what that is right away. I got an 8x plus 15 over 4x plus 10, and this is nothing more than a linear over linear. I know I should be able to do something with that. Of course I will. What I'm trying to do is I'm going to get a common denominator, so I need an 8x plus something to end up with a 4x plus 10. So what do I do? Well, I could actually see that's, let me see if I have this right. That would be a 2 outside of 4x plus 10. That's what I'm going to want, which means I'm going to be adding in a 20, because 2 times 10 is 20, which means outside of this I have to subtract my 20. And then don't forget that 15. So as you can see, that's how I've set it up. What does this end up looking like? Well, I get a 2, because my 4x plus 10, well actually let's spell it out. It'll be a 2 times 4x plus 10 divided by 4x plus 10. And that will be negative 20 plus 15, that will be negative 5 over, oh, might have enough room, 4x plus 10. What does that final thing look like? It looks like 2 minus, oops, not plus, minus, that minus is important, 5 over 4x plus 10. Let's make that look even more normal. Y equals negative 5 over 4 multiplied by 1 over x plus, now it's not 10 because I took a 4 outside of it, it's 2.5. Let's make sure we realize that. If I'm going to take this whole expansion factor out, I got to make sure that this guy gets treated right. Okay, so there we go. So what does this mean? What do I got? What are all the points? Well, I know that I have a vertical reflection. I got that negative. I know that I'm expanding by 5 over 4. That's a vertical expansion by 5 over 4. What's 2.5? X can plus 2.5 can't equal 0. I'm going to be left with an x not equal to negative 2.5. That is my vertical asymptote. And what is my horizontal asymptote? I almost forgot to write it down, didn't I? Look at that. Plus 2. So I actually have a horizontal asymptote as well. Equal to 2. So let's draw them all on that graph. So it's pretty clear about what happened. I've got my two asymptotes there, my y equals 2 and my x equals negative 2.5. And if I look at my 5 over 4, it expands a little bit, but not very much, so it's pretty tight to the asymptotes. And don't forget that vertical reflection. It's no longer in the upper right, lower left. It is now switched. So I'm thinking this is probably going to end up being my intersection point. I don't see anything else where it could happen, so let's hope that works out. But now we have to look at the other equation. So I look at that, y equals x over 2x plus 5 plus 2x, and it looks ugly and everything, but once again, take heart. We just need to give ourselves some common denominators, and perhaps this is going to work out great for us, so let's just try it here. So if I want to have a common denominator, I want to have x plus 2x times what? Well, it has to be multiplied by the other denominator. This is typical algebra. It shouldn't be very strange for you at all. And I'm going to be left with this. And what does that end up being? Well, I'm going to be left with a 4x squared plus 11x all over 2x plus 5. And that is nothing more than quadratic over a linear. And we already know what that's going to be. I can immediately see also it's also got no common factors. And because it has no common factors, I know that I'm going to end up with a regular vertical asymptote, but a slanted asymptote in its place. There is no horizontal asymptote. There will be a slanted asymptote. So how do I get my vertical asymptote? Well, that's easy. I'm just simply looking at this value right here. I say that x cannot equal, what is it, 5 over 2. Which is neat. That actually ends up being the exact same vertical asymptote as the other graph. So that was lucky. But the question is, how do I get the other asymptote? Well, there is nothing I can do except divide in and get that equation. So I'm looking at 2x plus 5 dividing into 4x squared plus 11x. And so in order to do that, I'm going to have a 2x. Well, I should add in that 0 too. Don't forget that. Let's not forget all the things we've learned. Plus 10x. That gives me a 1x plus 0. And I know that in order to get that, multiplying by 2 to get 1, I got to multiply by 0.5. And I'm going to get an x plus, you know what? I don't care. Why? Because I've got my equation. It's all done. I'm ready to go. This is the equation of my other asymptote. So what does that look like? Well, it's going to be at 0.5 intersection right there. And then I'm going to have something that goes up by 2, 1, 2, and over by 1 in a positive direction. 1, 2, over 1, 2, over by 5. So I'm not drawing this perfectly well, but you get an idea that I have something like that. Now, don't get too confused. Remember that that horizontal asymptote right here is not a part of this equation. I'm not interested in that. Now, what I'm curious about, though, is what side of that asymptote is it on? Now, there's only a few ways of figuring it out. So think for a moment about what you can do. So let's think about that for a moment. I have to figure it out, and it's not actually obvious when you deal with quadratics over linear. You have to try to figure out what is the plan. And so in this case, remember, I'm looking at this strange shape. So either it's going to end up looking like that, or it's going to end up looking like something like that. Okay, so how do I figure out which one is the proper response here? Well, let's just say if it was going to hit across, it looks like in both cases it's going to hit possibly across the x-axis. In other words, where y equals 0. So why don't we just simply solve for that and see what happens? So in other words, 0 equals 4x squared plus 11x all over 2x plus 5. Well, in that case, if that's equal to 0, I know that only the top part can be equal to 0. I can't have this equal to 0, or else I have an impossibility. So 0 equals 4x squared plus 11x. And that's equal to x outside of 4x plus 11. If I wanted to take out an x there, which means I actually have two solutions. One in which x itself equals 0. So I know that this equation, let me just draw in. So I know that at y equals 0, x equals, so it passes through this point right here. In fact, at this point I can probably stop, because now I know what side of the asymptotes I'm on. So why don't I just simply draw it? What's going to happen? I know it's passing through this point. It's intersecting here. So what's going to happen? I'm going to have something that looks like a little freaky, a little weird. And then on the other side, I know it's going to be going through here as well. But what I do know is it's not actually going to reach this graph as well. So it's actually, and this is kind of fascinating really when you think about it. At all points, you almost think it's going to intersect with each other here, but it's almost as if you think about it, it's as if this graph has got one up on this one. And no matter what point we're looking at, will always be slightly higher than the purple graph. So they're never going to end up touching each other. They're going to always be off from each other. However, this one, it's fairly obvious that right at this point right here,